Welcome to Algebra Bootcamp Topic 2, Evaluating Functions. We'll start by exploring what a function is. A function is just an input-output machine, and usually we input x values and output y values. Although there could be any two variables, it doesn't really matter. So for example, if our function machine is f of x equals x squared, that means whatever we input, x, what comes out as our output is x squared. So the independent variable is what goes in. So for example, if we were to input an a, our function machine would take that a and then square it, and its output would be a squared. Now, if we were to input a numerical value, like -2, our function would square that and output a +4. What if our function input is something a little bit more complicated, such as 3x? All right, so what's going to happen is our function is going to square that entire thing, 3x. It's going to square, which means multiply by itself. So it's going to do 3x times 3x, which is 9x squared. And so that's all a function is basically a machine. The f of x is just function notation. It's how we write it. This value in here is our input. This is what pops out. We can also look at a function with the different types of variables. So usually our independent variable is our x and our dependent variable is our y, although again it could be a and b or whatever. So in this case, our x is our input usually, and our y, our dependent variable, is our output. It's called independent and dependent because whatever we input is independent of anything else. We can input really anything we want so long as it's in our domain. The outputs are called dependent because they are dependent on what we input into our function. So I already gave an example if we want to look there, right? Our example could be f of x equals x squared. We're going to encounter a lot of different examples today. We could call this h of a is, the square root of a plus 7. That's an example. We've had functions that have restricted domains, which we'll talk about in our next video. Right? We couldn't plug in 0 here because we can't divide by 0, but this is still a function. We just have a restricted input. That's anything but 0. Here, we could not input negative values since we couldn't take the square root of negative ones. But these are all just examples of functions, input-output machines, basically. And then a topic that we will discuss later is a piecewise function, and that is just a function broken into different pieces. So for example, our function might be x squared when x is less than -1, but our function might be defined as the square root of x plus 3 when x is greater than or equal to -1. And so this function just happens to have two different pieces to it, depending on what x value we're plugging in. And we'll explore those at a later time. So that's just an example of a different type of function. Next, we'll move on to some examples. And then last, like always, will be your daily assignment. All right, so here are two examples. We see that we have two different functions. We have f of x and h of n. So we'll first look at f of x examples. And f of -5 means plug in -5 where you see the x value. So since f of x is defined up here as the square root, or sorry, the absolute value of x minus 2, we will plug in -5 where there's an x. And then we'll evaluate because we can here. We're given a numerical input. And so that means that our value will be a numerical one. So when we evaluate this, what's inside the absolute value is -7, and the absolute value of -7 is 7. So that would be our value there. Okay, this next one, we're actually given an input that has a variable in it, And that means that our output is not just going to be just a number, it's going to actually have a variable in it, almost always, unless the variables end up canceling. So that just means that I'm going to replace x with x plus 1. It's a little weird, but we can do it. So we'll replace x with x plus 1. And of course, we still have that minus 2 there at the end. Now, can we simplify this? Yes, we can. We can combine some like terms. So we'll have the absolute value of x minus 1 after we combine the positive 1 and the minus 2. And that is our final answer. We cannot get that any more simple because we have a variable in there. Okay, the next one we'll focus on is our h of n. And this one is a polynomial function, right? F of x was an absolute value function. This is just a polynomial function. In particular, it's a quadratic, right? Because it's degree 2, that's the highest exponent. And so we'll plug in -3 here for n. Of course, especially because our input's negative, we definitely need parentheses, although that is usually recommended. Now in this case, we want to plug in -3 both times we see an n. So everywhere there's an n, we replace it with -3 because that's where we are evaluating the function. And then we use our order of operations, right? So we make sure that we first take -3 to the second power, which of course gives us a positive 9. Over here, I can do the multiplication. This will give me a -12 or plus a -12, however you want to look at it. Then we can multiply -2 by 9 and get -18. Minus 12 more gives us a -30. And what that really means is that on this graph here, if we were to plot this, right, we would have the coordinate point -3, -30. You guys know that this is a downward opening parabola, and so we would have this coordinate point on that parabola. All right, I want to plug in one more thing for h of n here. And the next one's going to be plugging in a variable with a coefficient just to get some extra practice. So we'll plug in 2a. All right, so let's find h of 2a. That means everywhere there's an n, I'm going to plug in 2a. So it'll get squared, and then we'll plug it in and multiply it by 4. All right, so again, order of operations, we have to make sure that we first square 2a. Now, what does it mean to square 2a? It means 2a times 2a. That's what it means. So we're going to do the 2 times the 2, or 2 squared, and then the a times the a, or a squared. So we end up with 4a squared. I had to square both parts in there. Then we can simplify this term over here by multiplying 4 times 2a to get 8a. Then of course we'll multiply here, we'll get -8a squared plus 8a. Great. Okay, here's another example for us. We have a new function f of x. This is of course a cubic function because we have x cubed. And so the first thing we want to plug in will be 0. So when we plug in 0, we'll have 0 cubed plus 4. That one's not too bad. The second thing we want to plug in is 4a. So that means we're going to cube 4a, then add 4 to it. Now what does that mean to cube 4a? Well, that means we have to cube both parts. So we have to cube 4, so 4 cubed. Then we have to cube a, so a cubed. Well, 4 cubed is 64, and cubing a gives us a cubed. Then we add 4. We don't have any like terms, so that's our final answer. Okay, our last example before the assignment is g of a. We have another quadratic polynomial function here. All right, so the first thing we'll do is plug in -3. I'd like you guys to try this one. So I'm going to pause, and you can pause the video too to see how you do. All right, you can check to see that you found g of -3 correctly. Then we want to plug in x plus 2 for our next one. So g of x plus 2. So that means we're going to be squaring x plus 2 and then -3 times x plus 2. We're plugging it into both spots. Okay, what does it mean to square x plus 2? We're adding now, or subtracting, whatever. These are not being multiplied in here, so we can't just simply square each piece, right? We have to actually FOIL it out. So what this means is we're doing x plus 2 times x plus 2. That's what squaring x plus 2 means. Multiplying by -3 is just the distributive property. So we're going to distribute the -3 through here. So we'll have -3x minus 6 at the end. All right, so we still have a little bit of work to do with FOILing out the x plus 2. So we'll have our first times our first, right? X times x. Then we'll have our outsides, so plus 2x. Then we'll multiply our insides together. And then last, the 2 times the 2, which is 4. We still have the -3x minus 6 at the end. Then we can just combine our like terms. So those are all like, but I'm first going to bring down the x squared because it is the highest exponent. Then we have a 2x and a 2x, which is a 4x, minus 3x, so we still have a positive 1x. Then we have a positive 4 and a -6, which will give us a -2. So there is our answer for plugging in x plus 2. So just be careful, right? Depending on what you're plugging in, make sure you're plugging it into every time there's a variable in your function. Make sure that you are doing the correct algebra, depending on how it gets plugged in, right? Squaring something, what does that mean? Distributive property, what does that mean? Combining like terms, what does that mean? So just be aware of each step, making sure you're being diligent at each step. Our last slide will show your assignment. Okay, here